Now we will continue the chapter Mechanical Properties of Solids. Now we will see the sharing modulus of elasticity or modulus of rigidity. Okay, now let's draw a cube. If we apply force tangential to the cube, it will expand like this. This is the longitudinal. So it is defined as the shearing stress upon shearing strain. Shearing stress means force upon area. Here it is X. Total is L. This L, it is X. So X upon L. So it is FL upon AX, or tan theta is equal to X upon L. It is applied for solids only. Now we will see some problems. First copy this. Okay, now we will discuss the problems. First problem. A 4 centimeter cube has its upper face displaced by 0.1 millimeter by a tangential force of 16 kilonewtons. Calculate the shearing modulus. Okay, in the question they have given the length, the displaced one, the force, and the area here. Now we will solve. Area of the cube is L cubed. So 4 into 10 to the power of minus 2 meter 4 cube. It will become 64 into 10 to the power of minus 6 meter cube. Now the length is 4 into 10 to the power of minus 2 meters. And X is 0.1 into 10 to the power of minus 3 meter, and the force is 16 into 10 cube Newton. Now we want to solve the shear modulus. The direct one. So 16 into 10 cube into length, that is 64 into 10 to the power of minus 6 meter cube upon area. 1 minute, here there is small mistake. Here the length is 4 into 10 to the power of minus 2 meters upon it is 64 into 10 to the power of minus 6 into 10 to the power of minus 4. Now it is 16. So this will cancel and here it will become 10 upon 10 to the power of minus 6 into 10 to the power of minus 4 will become 10 to the power of minus 10. So 10 to the power of 11 Newton. Here it will Newton meter upon meter into meter square. So Newton per meter square it will become. Okay. Let's check as is correct or not. Okay, as is correct. Now let's solve the next question. First copy this. Okay, now we will solve the next problem. Now the second problem. Okay. A square lead slab of side 50 centimeter and thickness of 10 centimeter is subjected to a force of 9 into 10 to the power of 4 Newton. The lower edge is riveted. How much the upper edge displaced if shear modulus of lead is 5.6 into 10 to the power of 8 Pascal. Now in the question they have given the area means length per square is length into breadth. Area per square, that is 50 into 10 into 10 to the power of minus 4 meter square. So 500 into 10 to the power of minus 4 meter square. And force is 9 into 10 to the power of 4 newtons. And here modulus is 5.6 into 10 to the power of 8 Pascal. Now the length is 50. 50 into 10 to the power of minus 2 meter. Now they have given all. We want to find x. So 5.6 into 10 to the power of 8 is equal to the force 9 into 10 to the power of 4 upon 500 into 10 to the power of minus 4 into L by x. So 50 into 10 to the power of minus 2 upon x. So here it will become 10 to the power of 8, 10 to the power of minus 6. 10 to the power of minus 6 it will be. 8, 6. So here it will be 10 to 10 square. Into. So ones, tens. So 0.9 upon x. It will become is equal to 0.9 upon x. Now it will x is equal to 9 divided by 5.6 into 10 cubed. This is the x. Okay, now we have completed the modulus of rigidity including problems. Now we will see the factors affecting elasticity. First copy this. Okay, now we will discuss the factors affecting elasticity. Okay, factors affecting elasticity. Now, elasticity depends upon four factors. Elasticity depends upon four factors. That is temperature, two, impurities, three, hammering, four, annealing and rolling. Now, as temperature increases, elasticity will decrease. Now, the impurities will dependent on impurities. Okay. Now, hammering. As we do hammering, elasticity will decrease. Now, annealing and rolling, it will increase the elasticity. Okay. Now we have completed this factor affecting the elasticity. Now we will see a small problem. First copy this. Okay. Okay. First, elasticity formula is stress upon strain. Okay. Now, here it is stress. Here it is strain. Then, here it is y1 and y2. Now, here which is greater, y1 or y2? Obviously it is y1. So, y1 is greater than y2 because stress and strains give elasticity. So, y1, that means here theta 1 and theta 2. So theta 1 is greater than theta 2. So y1 is equal to y2. So, and it is inversely proportional to temperature. T1 is less than T2. This is the if stress and strain are given in y and x axis. What happens if strain and stress are given in y and x axis? We will see. Let's copy. Okay. Strain and stress. This is for stress but strain. Now strain but stress. Here theta 2 is greater than theta 1 because stress is greater. Sorry, here theta 1 is greater than theta 2. But the stress is on the x-axis and the strain is the y-axis. Less strain, more y. More y, less strain. So here the strain is max. At this point, the stress is more and strain is less. So y2 is greater than y1. By keeping the strain as constant, and here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So y1 has 4 value in stress and y2 has 10 value in stress. So y2 is greater than y1. But temperature is inversely proportional to the is inversely proportional to the x modulus. So T2 is T1 is greater than T2. So from this you can see but for stress but strain and strain but stress here theta1 is same both. But y1 and y2 are inverse or reverse. Here y1 is greater than y2 and y2 is greater than y1. It is for either stress, Young's modulus, bulk modulus or modulus of rigidity. Now we will discuss the Poisson ratio. Okay, first copy this. Okay, now we will see the Poisson ratio. Okay, Poisson ratio. Poisson's ratio. It is denoted by sigma. Okay. First, a rod of L and area A or diameter you can say. Now this subject it is force. So the length will increase. Is delta L and the diameter will decrease. Here it is delta D. Now the first we will see the for length. It is lateral, this longitudinal strain. Longitudinal strain. That means delta L upon L, because for length is increasing in the longitudinal axis. Now lateral strain, it is minus delta D upon D. Now Poisson's ratio. Poisson's ratio is lateral strain upon longitudinal strain. Okay. Now we will substitute the values. Minus delta D upon D upon delta L upon L to the sigma. Now there are values. For theoretical purpose, the value is lies between -1 is less than sigma and it is less than 0.5. This is for the theoretical purpose. For practical purpose, it is 0 greater than sigma greater than 0.5. Okay, it is the order. Now we have completed the Poisson's ratio. It is minus negative because the diameter is decreasing. Look here, the diameter is decreasing and length is increasing. Now we have completed the Poisson's ratio. Now there is a relationship. Relation between y, b, eta and sigma. Okay, b is equal to y by 3 into 1 minus 2 sigma. It is. Now eta is equal to y by 2 into 1 plus sigma. Now there is another relation, that is 9 by y is equal to 1 by 3 plus, this is relation number 1 and relation number 2. The third relation is 9 by y is equal to 1 by v plus 3 by eta. Okay. Now we will see the third. That is fourth is sigma is equal to 3b minus 2 eta upon 2n plus 6b. This is the four formulas. Okay, this is the first, second, third and fourth. Okay, now we have completed the Poisson's ratio. We will discuss some problems related. First, copy this. Okay. Okay. Question 1. Determine the Poisson ratio of the material of a wire whose volume remains constant under external normal stress. Okay. Now we will see for the wire the volume is equal to pi d square upon 4 into L minus here. Now here volume is constant. So from this pi here d square into L is equal to constant. Now that is delta V by V. Now we will write here delta d upon d whole square into delta L upon L is equal to constant. So we can write this as minus 1 by 2 delta d by d is plus delta L by L is equal to constant. So from this minus 1 by 2 into delta d by d is equal to minus delta L by L. So from this we can write the ratio, that is delta d by d upon delta L by L is equal to 1 by 2. But there is negative here, so we can write negative. It is minus 0.5. I have completed the problem. The problem states that under normal stress volume is constant. So you want to find out the Poisson's ratio. So the volume is pi d square by 4 into L. Here the volume is constant. That is pi minus d square upon L is called constant. By dividing from the unit and dimension chapter uncertainty law, it is delta d by d whole square into L by L. It is called constant. Here it is positive, so it is constant. From this we can get this. So we have completed the Poisson's ratio. The first problem. First copy this. We will discuss the second problem. Okay, second problem. Okay, second problem. A material having sigma is equal to 0.2. A load is applied on it. Due to which it suffers the longitudinal strain. That is 3 into 10 to the power of minus 3. Find out the change in value. It is percentage change. Percentage change in volume. Okay, now we will discuss. Here the question, sigma is equal to 0.2 and delta L by L is equal to 3 into 10 to the power of minus 3. And we want to find out delta V by V into 100 is equal to dash. First we know that V is equal to A into L and area is equal to R square into L. So delta V by V is equal to 1 by 2 into delta R upon R plus delta L upon L. Now we want percentage. When delta V by V into 100 is equal to delta R upon 2R plus delta L upon L into 100. Okay, I think it is not visibly. First, write this. Now from this we can get delta D upon D is equal to first we will write the sigma is equal to delta D upon D upon 3 into 10 to the power of minus 3. So from this delta R upon R, it is delta D is equal to R. So upward term can be cancelled into 3 into 10 power of minus 3. So minus delta R upon R is equal to 2 into 3 into 10 to the power of 2 into 3. Here 10 to the power of minus 1, 10 to the power of minus 4. So it will become delta R by R is equal to 6 into 10 to the minus 6 into 10 to the power of minus 4. Okay, now we will substitute here delta V by V is equal to minus 1 by 2. So it is 1 by 2. So it will become minus 3 into to the power of minus 4 plus 3 into 10 to the power of minus 3. From this we can solve minus 0.3 plus 1 into 10 to the power of minus 3. You get 3. Okay, it will become 2.7 into 10 to the power of minus 3. Here they have given delta V by V. Okay. Now we want to find delta V by V into 100. So 2.7 by 7, 2.7 10 to the power minus 3 into 10 square. It will become 10 to the power of minus 1. So 27 into 10 square it will become. So we have completed the Poisson Ratio second problem. Copy this. There is a small mistake here. Here it is square. So it will become 6. From this it will become 6. So minus 2.4. Okay. Okay, now we have completed this session 3 of the mechanical properties of solids. In the next session, we will discuss about the remaining topics of the mechanical properties of solids.